Now let's start with the load and store instruction. These both instructions are the foundational instructions for moving the data between register and the main memory. Unlike Intel architecture, in ARM architecture, only these two instructions are capable for moving the data between register and the main memory. The LDR or the load instruction, this loads the value from the memory into a register, while in the store instruction, this store the value from a register into a memory. As you can see in the syntax of the LDR, first you require a destination and the address from which you are loading a memory or the value, while in the store instruction you require a source and then address. Source is the location from where you are getting the value and the address where you are moving the value. Now let's check load and store instruction in CPU later. ARM uses load and store architecture. That means only load and store instructions are allowed to access memory. Unlike Intel architecture, where complex instructions can also access the memory and change them. Now let's start with the video. First I'm gonna add a data section where you can store data that you cannot store directly into a register. As you can see, the data section have changed the color like a keyboard. Now let's declare a variable that will be a word variable with an immediate value. Let's give the variable immediate value 3. Let's be a creative here and name the variable. Here I have declared a variable with a value 3. Now let's declare another variable. Let's give this variable value 5. Now let's start with the load instruction. Now you would be thinking, why cannot we be using the move instruction to move the value or an address of the variable into a register? You simply cannot use that. And if you did so, your compiler will throw an exception that this is not permitted. Now in this instruction, you would be thinking, why did I add this equal to sign? The LDR instruction with an equal to sign is used to store the load address or is used to load the address of a variable into a register. Now this instruction without equal to sign loads the value at the memory address labeled variable or labeled VAR. Now I really did a mistake at naming. Let's name it VAR1. If you're not having equal to sign, it will try to store the value at VAR into R0. To access the address of VAR, we need to add equal to sign. Now let's compile and check that into the register. Now let's step into the instruction. As you can see, it has been added to R0. Now you would be thinking the value was 3 and it's not even closer to 3 or doesn't seem like an address. If you are working with an Intel or you are doing directly into your PC, this is not kind of address you will get into your register. Now let's look at the memory. If you see, 3 has been stored here, and we even declared another variable that was 5, and 5 seems to be here. As you know, in 32-bit architecture, this is a address 0, and similarly this is address 4 by the difference of the 4 bytes, and this would be address 8 and this would be address 12. What if you need to directly store the value of that variable? As we have already stored the address of the variable into R0, it would be now pretty easy to do that. Now let's store the value of variable 1 into R1. Now this instruction loads the value from the memory address stored in register R0 into register R1. Now these square brackets are pretty much like dereferencing the pointer in C. Instead, here the value of R0, or the value that was stored in the address of R0, will be stored into R1. Now let's compile and check it into memory. As you can see, now R1 contains value 3. Now you would be thinking, previously it was having the value 8. Now it has been switched to value 10. Why this so? As you can see, now our value 3 has been moved to address 10. Moving of the values is pretty much common. You don't need to worry about that. Now let's check out the store instruction. As I have previously mentioned in the previous part of the video, that store instruction is quite the opposite of the LDR instruction, where in the LDR you are storing the address or value from the address into a register. It's kind of moving from memory to register, while in the store instruction you are kind of moving from the register to memory, where you can store the value from the register or the address from the register into your memory. So we have already written some code where we have stored the value from the variable 1 into register R1. Now let's use the value from the variable 1 and that has been stored into register 1 to move the value from register 1 into variable 2 that has been holding the value 5. So first let's load the address of the variable 2. Now let's load that address into register 0 because we don't need that anymore. For the store instruction, we are using the str mimic, and the source will be our R1 and the destination is gonna be R0, as R0 is containing the address of variable 2. We are gonna use that square braces again and R0. Now let's check out how it performs in the memory after when you compile it. As you can check in the memory, the place they are holding is 4, 5, 4, 4, 8, 12, 16, 20, 24 and 28. The value 5 has been held at the address 28. So the R0 should be 28 after when you step over. As you can see, 1 is a 28 in the decimal, and after the store instruction, this value 5 should be changed into value 3 from the register R1. As you can see, the value that has been stored here was 5, now has been changed into value 3 from the register R1. So this is how you can move the data from memory to register and register to memory.